Okay, so in this one it's quite similar to the ones I've done before, except at this one we're starting from a point that isn't on ground level. So we are still going to be using Suvat. I'm just going to draw a little diagram just so that people can understand what's going on. Okay. So this is the ground here. So it says a ball is being projected upwards from point X, which is 6 meters above the ground. So this is my point X here, which is 7 meters above the ground. So an object is being thrown up in the air. It will get to a point where the speed will no longer be upwards, and then it will then fall down to the ground. Okay, something like that. So we're going to start with Suvat because we were asked to find the greatest height above the ground that it reaches. So Suvat. So we're trying to find the height, so that's going to be the S that we're looking for. We know the velocity at the beginning is 21, that's the speed that when we're throwing it. Now, I'm making everything upwards positive, so the speed going up of the object is positive 21, but the acceleration is going to be negative because the object's obviously being pulled down by gravity. So gravity is in that direction. Okay, and then obviously the speed starts off being positive in the upwards direction. So when it's reaching the greatest height, that means that the velocity is going to be 0 before it then obviously starts travelling downwards. So using our formulas, so the one that uses all of those is going to be number 4, okay? So v squared equals u squared plus 2as, and then we sub them all in. So 0 squared equals 21 squared plus 2 times minus 9.8 times s. So that's going to be 0 equals 441 minus 19.8s. No, 19.6s. And then we add that to both sides. So 19.6s is equal to 441. So the distance is going to be 441 divided by 19.6. Okay, and we get 22.5. Okay, but this is from point X. Okay, not from the ground. So what we then need to do is add 7 onto that answer, which is 29.5 meters, and that's from the ground. Okay, so it's just being careful, making sure that you know or understand what's actually happening. Okay, so for B, we're trying to work out the time of flight of the ball. So again, we're going to be using Suvat. So we know the u is 21, that's the initial speed. We know the acceleration is negative 9.8 because of gravity. We don't know the time, that's what we're looking for. We don't know the speed, but the s, the distance, so if I look at the diagram, so you start up here, that's when the ball was thrown, it reached the highest point, which was 19.5, and then it made its way down. So the ground is actually further down than what the ball was thrown at. So the s is going to be -7 because the ground is 7 meters below where it was actually thrown from. Okay, so the equation that we can use is s equals ut plus a half at squared, and then we just sub it all in. So -7, 21t plus a half times minus 9.8 t squared. Move it up a little bit. Just going to simplify it. And then I'm going to put everything on, oh, missing the one there. I'm going to move everything onto the left hand side just so that the t squared is positive. Again, you don't need to put a random equals there. Equals 0. You don't have to do this, but obviously I quite like it. And then once we get this point, I wouldn't try and factorise it because of the 4.9, which is a bit mean. You can use quadratic formula, or you can just use, if you've got a scientific calculator, which you should have, you can use that. Polynomial 2, 4.9 minus 21 minus 7. So we get 2, so we get t is 4.6. And we get minus 0.3. Obviously it can't be the negative one, so it's going to be 4.6.